Hey everybody! Today we're going to work on multiple step problems that involve measurement. One of the skills that was discussed in your Envisions video was the process of answering hidden questions to help you solve word problems. So let's talk a little bit about what we mean when we say that a word problem has hidden questions. Okay, let's think about what hidden questions are. Hidden questions are information that is not stated in the problem, but that you must find or calculate before you can solve the problem. So in order to determine what the hidden question is, you're going to need to draw a conclusion using what is included or what is stated in the problem. Let's look at an example of what that might look like. Okay, let's look at the example that was used in your Envisions video. In this video, they say that you're being asked to find the perimeter of the pool. Remember that perimeter is the distance around the edge of the shape. So one way to find the perimeter is to add side plus side plus side plus side. This would work best if you were doing a rectangle like this shape. Now let's look at the information that's given. We're being told that one side of the rectangle is 60 feet and the other side is 25 yards. Of course, we know that we can't calculate the perimeter of this swimming pool with the information that we currently have because we can't combine feet and yards. So the hidden question, or the question that we must calculate before we can find the perimeter of the pool, is how many feet are in 25 yards. And I'm saying that we need to draw a conclusion in order to figure that out, because as readers, we know that sometimes there are things that we can figure out that are not directly stated in the text that we're reading. And this is true of math problems, just the way it's also true of stories that you might read or assignments you might work on for Mrs. McCluskey in reading class. Here we're being directly told to find the perimeter of the pool, and then we use our background knowledge to determine that before we can do that, we need to figure out how many feet are in 25 yards. Once we know that, then we can calculate the perimeter. So that's an example of the hidden question. Okay, let's look at number 1 together. The directions tell us to answer the hidden question or questions and then solve. Isabel took 24 minutes to run around the track 6 times. And John took 3 minutes to run around the track once. Which student was faster? So here we need to think about the information that we are given before we can figure out what the hidden question is. So in order to do this, I'm going to draw a picture to represent what we're told. I've drawn 2 running tracks, and one is going to represent John's running time, and the other one is going to represent Isabel's running time. We're told that Isabel took 24 minutes, and that in that time, she ran around the track 6 times. And then we're told that John ran around the track 3 minutes, or that he took 3 minutes to run around the track just 1 time. Now, you may look at these numbers and immediately say that John was way faster because 3 minutes is a lot less than 24 minutes. But when you look more closely, you're going to see that we have 2 different rates being given here. One is 3 minutes to run around the track just 1 time, whereas for Isabel's time, we're told that she's run around the track not just once, but 2, 3, 4, 5, 6 times. So that tells me that the hidden question is, how long did it take Isabel to run around the track just 1 time? Let's assume that she ran at the same speed for each of her 6 laps around the track. If that's the case, we can take her 24 total minutes that she was running, divide it by the 6 times that she lapped the track, and we'll learn that she probably took 4 minutes per lap, or 4 minutes for just 1 time around the track. Now we're in a better position to answer the question, who was faster? John with 3 minutes for one lap, or Isabel with 4 minutes per lap? You can go ahead and answer that question on your own. Okay, let's look at question 2. Nancy is saving $2 from her allowance every week. Marco is saving $1 the first week, $2 the second week, $3 the third, and so on. At the end of 10 weeks, who will have saved more money, and how much more money? First, let's think about what we're told before we get to what we're not told. Always start with what you know, and then deal with what you don't know. Okay, so here's Nancy, and I'm going to make an XY table that's going to represent the weeks going by, week 1, week 2, week 3, week 4, and so on, and the amount of money that she's saving each week. Here we're told that she's going to save $2 every week. So she's not changing her rate at which she's saving. She's going to keep that consistent. Let's compare that with Marco. Marco has a different strategy for saving. He's going to save for the same amount of time that Nancy does, 10 weeks altogether. But instead of saving the same amount each week, he's going to increase by $1 after each week. So we have to figure out who's going to save more money and how much more. Let's think about what hidden question we need to figure out before we can address who has saved more money. Before we can compare Nancy's money to Marco's money, we need to know how much money each person will have saved after 10 weeks. How much money will Nancy have saved after 10 weeks? And how much money will Marco have saved after 10 weeks? So in order to figure that out, I think I'm going to add a third table, or a third column, I should say, to my chart. And this third column is going to be where I'll record the total. It seems to me that for Nancy, let's see, after 1 week, she'll have $2. After 2 weeks, she'll have $4. After 3 weeks, she'll have $6. And after 4 weeks, she'll have $8. It seems like this is a pretty simple case of multiplying the number of weeks times $2. Number of weeks times $2 per week. So to figure out how much she will have saved after 10 weeks, I can just multiply 10 times 2, and I'll see that she has earned $20. Okay, so that's one hidden question that's been answered. $20 for Nancy. Let's see if we can figure something out, like a system that we can use for Marco's savings. So after 1 week, he will have saved $1. That's easy enough. After 2 weeks, he will have saved $1 plus $2 for a total of $3. And for the next week, he will have saved his $3 from the previous week plus 3, and that will be 6. Then we can just add the money from the previous weeks plus 4 to get a total of 10. On the next slide, I'm going to show you the table that I made to calculate the total amount he would have saved after 10 weeks. As you can see, once you add up the total amount of money that he's going to earn after 10 weeks is $55. So now we can return to our original question. At the end of 10 weeks, who will have saved more money and how much more? We know that Isabel only saved $20, whereas Marco saved a total of $55. So it's clear that Marco saved more, and then you can just calculate how much more he saved and answer the question. Bonus points if you can figure out a system that we could have used, maybe using a variable like the letter W or maybe the letter X. See if you can find out a system that we could have used to calculate the total amount of money that Marco would have saved for any number of weeks. Okay, number 3 and number 4, I'm going to let you solve on your own. Number 3 is a multiple choice question, but I would like you to upload some written work to go with your answer choice. Number 4 is a question that asks you to write a sentence. I know how much you love those. Make sure that when you're writing a sentence, you include math vocabulary words. An important vocabulary word that you might use in this question is the word volume. Remember that the word volume refers to the amount of something that can fit inside of a container. So for example, in this question, the volume of the rectangular vase is how much water that can fit inside that vase. Okay, good luck and happy problem solving, everyone. Let me know if you have any questions.